Hey guys, how's everything going? This is JSer. In this video, I'm going to take a look at 133 clone graph. We're given a reference of a node in a connected, undirected graph. Return a deep copy of the graph. Each node in the graph contains a val and a list of its neighbors. For simplicity's sake, each node's value is the same as the node index. For example, the first node with val 1, the second node with val 2. And so on. The graph is represented in a test case using adjacent list. The given node will always be the first node with val 1. I must return a copy of the given node as reference to the clone graph. So for example, we're given this, like 1, 2, 3, 4. I need to return 1, 2, 3, 4. The nodes must be new, and the graph should be the same. I cannot return the same graph. And the node, like this, the nodes are cloned, but the graph is messed up. So it should be 1 connected to 2, but now we got 1, 2, 3, 4. Well, this is, I think, so for a graph, what are the elements? What makes a graph? The first one is the nodes, right? And another one is the relationship between this node. It says the neighbors. So what I'm thinking of is that we're given the nodes, okay, and now because it's undirected, I'll just go BFS and search and just traverse through the graph. Yeah, I'll traverse through the graph, and then when I traverse through the graph, I will create the new nodes of each node, and then collect them up, right? So for case like here, we get 1, okay. We put them in a queue, and then we'll process it. Remember, put them in a queue is different from processing them. Okay, I put this queue, so I handle 1 first. When I handle it, I first search if this one is cloned or not. If not, I will create a new one, and then I will put 2 and 4 in a queue, right? But how we handle this relationship? So there's a problem. When I put 2 and 4 in, I check if 2 and 4 are in the map, the clone map. I mean, if it is cloned or not. If it is cloned, I will connect it, right? So 2, it's not cloned yet. So I create a new one, put it here, and I connect this one to 2, and then it will become, and then I'll put the neighbors of 2 in it. So 1, 3. So now here's the problem: is that 1 is already traversed, right? I cannot put it back, so I need to track if 1 the node is traversed or not. So how can I do that? Well, I just keep another map, right? Say if nodes is traversed or not. Mark it. So this is traversed. I'll put 3 in, and then I come to 4. 4 is not cloned yet. I create a 4 and connect it and put the next one in. But these 3 and 2 might be the same, right? So it might be duplicate. For that case, I think when I put in a queue, I first or I can just put it in. When I process a node, if it is already processed, I'll skip. Well, that's simple, right? Yeah. So the idea is done. I create a clone map node, cloned node, right? Another one is traverse map. set. Okay, traverse set. Okay, the idea is BFS to traverse the graph, use above set to avoid a circle. Every time when process a node, check if it is already traversed. And then for each labor, for the neighbor, it will be for each neighbor, if it is not traversed, and what? And okay, it is not traversed, and there's a sub if not cloned. By checking the clone map, we create a new one, create a new node, and then connect the node's clone, right? And what? Push the neighbor into the queue, and do this over and over again. Finally, at last, return the clone of cloned input node. Right? Cool. So let's try to do it. The first one, we'll create a clone map, and then create traversed equals new set. Okay, now create a queue, create a node, put node in. If this node is null, the node will be what? The node will be like this, right? So if node is null, we just return null. Okay, we put the queue in. While queue is not empty, we shift the element out. We shift the element out, which is head equals queue shift. So now we'll start checking this, right? So when I put in a queue, so there should be a new node. Or we should just put them and create a node, but we don't know where. We don't know where they are, right? Okay, I'll const clone head. New clone the head. New what? New node. Ooh. New node. Node val. And if undefined, it will be empty array. So this is okay. And we set, right? Clone map. Clone map. Set node. Clone head. Or we can use the index just to use array, but we don't know. Well, use set is okay, I think. Okay, now when we get it, when we shift it out, if it is already traversed, we will skip, right? So if traversed has head, we just continue, we do nothing, and don't forget to add it, add head at the end. Now we're handling their children, their neighbors. So for neighbor of cloned, of head, neighbors. What we do, we check if it is traversed or not. If it is already traversed, if it is traversed, we still need to connect, right? I made a mistake. For each node, if not clone, create a new node, connect a node, and here, if it is not traversed, push a node in the queue. Cool. So if clone the head, it's just clone map has, if it is cloned, right? It means the neighbor has a clone. Then we just set it up. So neighbors is array. So this one is actually okay. Const. I'll make it shorter like this. Const clone head equals clone map get head. Now, so if the clone map has neighbor, it means there is already a node in a clone. We will set clone's head, the neighbors, push the neighbor, clone get neighbor, right? Yeah, this is when there's already a node in the clones. So we connect it. If it is not, we will create new one, right? Cloned neighbor. Am I spelling the neighbor right? Seems right. Neighbor. Right. Clone neighbor means new node, which is neighbor val. We clone it and cloned head. Neighbors push it. We push the clone neighbor and add the clone map, right? So set neighbor clone neighbors. Yeah, and then we will check if it is a traversed. If it is not traversed yet, queue it. So if traversed as neighbor we will push in a queue push a neighbor, and then this neighbor will be handled in next round. Cool. And finally, return the clone map get node, right? Let's try to review our code before we try to run it. So for example, like this, we get 1, 2, 3, 4. The queue will be 1. The clone map will set 1 and a new one. Now we first get 1 out because it's not traversed yet. We'll continue. So we get the head, which is a clone one, and for each neighbor, which is 2, 4, for each one. The clone map doesn't have anything, so we're good here. We will first clone the neighbor, 2, right? First we handle with 2, and set the 1 connect 1 and 2, and then clone the map set these two. Now, because it's not traversed yet, we push 2 in a queue. The same for 4, so we got 1, 2, 4. Now we handle 2, right? Now we handle 2, get 2 out, and it is not traversed yet. And we get this node, which is the clone 2. And now we handle the neighbors, which is 1 and 3. Because clone 1 has 1, we will push its own direction, undirected. So okay, 2, 4, 1, 3. Oh yeah, this is right. So we push because it has this one. So we push the we add the connection, connected these two, and then we go to here because traversed is already traversed, so right, we skip push, and we go to 3. 3 is not in the map, is not cloned yet. We create a new one. Okay, now we had 1, 2, 3, and 3 is not traversed. We push into the queue. So you got the 4, 3. Now we go to 4. For neighbor 1, clone head because it's already there, this one. So we add it to the neighbors, and then because 1 is already traversed, we don't add to the queue. We go to 3. So the queue becomes the 3. The 3 already has the map, has the clone. So we add to the neighbors, and then because 3 is not traversed, so we push 3 in. So the queue actually has 2 3s, but it doesn't matter. We get the 3 out, not traversed, and get the clone 3. Check the neighbors, 2, 4 already there. We connect them, and then 2, 3 are all traversed. We don't do nothing. And then this 3 is traversed. And then get 3 again is already traversed. So we continue. I think so. This should work, right? Like this, it's simple. Uncode. Yeah, cool, nice. One time passed, nice. Finally, seems like I'm get a little like become better and better. Good news. Time. Well, we BFS for everything. There might be some duplicates, but I think it's linear time for the nodes count. Okay, node count. So even we have some, we know we're not getting back, right? So the worst case is that all the nodes will point at the same, connect to the same nodes. Well, that's still, we'll just go, that will be skipped here. For this case, we check 1 and check 2 and put 3, check 1, 4 and get 3, right? If these are different nodes, totally different nodes, it will be a tree and it will be exactly linear time. But now there are duplicates. The worst case would be, how can I interpret this? If there's a 5 and we connect them together, would be DFS better. 1, connect 2, 4, 3, 2, 1. DFS might be better. So BFS is like a little waste of time for this 3 here. If we're doing DFS, we use a stack. We push 1 in and process it and push their children 2, 4 in it, and process 2 and push 3 in, and then process 3 and then we handle 4. So If you use a stack, it's better. Yeah, anyway, the space for our solution, we use a clone map, which is the linear time, a linear space, and traverse linear space, so it's linear. It's still the node count. Let's try to see if we can use DFS, right? This is our DFS version. The BFS, I think we're doing the same, basically. The clone map, still we need it. Traverse, still need it. Rather than the queue, we create a stack. Of course, the clone map was set node to new. This doesn't change. While the stack is not empty, we'll pop the top, right? Stack, we pop it. So when we process it, we don't need to put it back, right? So yeah. So because we're using DFS, like 1, 2, 3, 4, like if 4 is connected, we push, we pop 2 and push 4, 3 in and handle 3. There must still might be 4 in the stack, right? Because it's not traversed yet, and we don't know whether they are not in the stack. So there will still be, still needs the check. Well, traverse has the top. We continue, and the traverse at the top. Okay. Now cloned is, we get the top for each neighbor. Well, for each neighbor. For the clone map, if it has it, we set it up. If it does not, we copy it and set it up. If it is not traversed, we push them in. This is a stack. We push the neighbor. Well, so, and then let's try. So this is done actually. It's a little different, but let's see what is different from the previous one. Okay, let's analyze the algorithm. First we get 1, and then we pop it up. A cloned 1. Okay, this is the clone. We get 1 out, and then it's not traversed, so we continue, and we get the cloned 1. Now for each neighbor 2, 4. If it has the if there's no clone yet, so we create a clone. We click them up and set the map. Okay, and because it's not traversed yet, right? So I push 2 in. Cool. And do the same. Add 4, connect them, push 4 in. And now we'll handle 4, different from previous one. We'll handle 4, and we will do the same. 4 is not traversed, and there's a 4 here. The neighbor will be 1, 3. 1 is already there, we connect them. 3 is not, we create 1 and connect them. And then 1 is a traverse, so we don't push. And 3 is not, so we push 3 in. And traverse set 4 down. And now we'll handle 3, right? We'll handle 3. Again, we connect 4. And then again, we connect 2. But both 4 is already traversed, but 2 is not. So actually, we will push 2 in. Right? So actually, this is the same. There'll still be some duplicate nodes in the same stack or queue, but it works. But which means this is actually DFS, and the previous one is BFS. Doesn't change so much for this particular problem. Okay, good. So that's all for this one. BFS, DFS. Remember, BFS a queue, DFS a stack. Okay, see you next time. Bye bye.